Again, the discussion of the study pack 15.2 alkenes, last bit of it under polymerization. Let's complete this and start the next session, which is the haloalkanes. I think I completed up to the mechanism was done last week. Right. Let's begin from the synthetic polymers. Now, polymers are long chain macromolecules which are formed by small, tiny molecules joining together. Now, as you have done the basics of the polymers in O levels, you know these tiny molecules are referred to as monomers, right? So the process of monomers joining together to form the polymer is referred to as polymerization, right? So there are two types of polymers, mainly addition and condensation polymers. A classification of the polymers as addition and condensation is based on the type of reaction which takes place during the polymerization. If you take addition polymer, it is addition reaction which takes place where a across the carbon-carbon double bonds, the monomers are combined together. And during addition polymerization, since addition reaction which takes place, there's no byproducts produced. And also, in some situations, same kind of monomer combines to form the addition polymer. So if the same kind of monomer combines to form the addition polymer, such addition polymer can also be referred to as homopolymer because the same type of monomer combines. As for condensation, the condensation polymer is elimination reaction takes place where when monomers combine together, the monomers are combined via elimination reaction. In fact, in the mechanism I'm explaining is addition followed by elimination. So that's why we call it as such reactions as condensation reactions. So because elimination occurs there, a simple molecule such as water or hydrogen chloride can be produced as a byproduct. And some situations in condensation polymers, different types of monomers combine. Sometimes even same type can combine. So if different types combine, condensation polymer can be referred to as heteropolymer. Heteropolymer, like addition polymer, is known as a homopolymer if the same type of monomer combines, whereas condensation polymer is referred to as heteropolymer because if there's different types of monomers combined. If not, it is referred to as the copolymer, right? So let's see how the addition polymer polyethene is produced by polymerization of ethene molecules. Now, ethene is a monomer which contains, as you know, the carbon-carbon double bond. So many ethene molecules polymerizes to form polyethene molecule. So what happens here is that the pi bond breaks. Now, if I'm to say, so this is one ethene monomer, right? And many, I put N in front of it to show many ethene monomers polymerizes under certain conditions of high temperature and pressure. Those conditions are not necessary for us to know. And you can notice now, I'm going to draw two ethene molecules next to each other. So you have the pi bond. This is ethene molecule. So I see what happens is that the pi bond of each ethene molecule breaks, and atom receives, each carbon receives one electron, and you can see now this carbon has an unbonded electron as well as the other carbon. So those two electrons combine together to form the sigma bond. The pi bond breaks and turns into a sigma bond, right? So this continues till many monomers are joined. So many monomers, many means polymer. So here the monomer is ethene, therefore the polymer is named as polyethene. So this is ethene monomer, and this is polyethene, that's the polymer. I notice here, this C2H4 group, repeats throughout, right? It repeats throughout. You can see the C2H2 here, the C2H4, C2H4. That C2H4 is referred to as the repeating unit. That's referred to as the repeating unit. So that unit repeats throughout the structure. So therefore, instead of writing the whole reaction this way, we can summarize it or write the reaction in short, the whole polymer reaction in this method. Now you have the monomer here, and then you just draw one repeating unit, just one repeating unit. Remember, the repeating unit does not have a carbon-carbon double bond, whereas the monomer has carbon-carbon double bond. You just draw one repeating unit, put a square bracket, and put N, this same N, right, over here, right? So in polyethylene, this N number is about roughly around between 500 to 1500. So if N number is very high, then you get high density polyethylene. We call those as HDPE, high density polyethylene. And it's the N number is very high, thick polyethylene. And if the N number is low, we get the low density polyethylene. We say LDPE, right? LDPE, right? So this is how you write in short the above polymerization reaction, right? So the monomer will have a double bond. The polymer will not have the double bond in addition polymer, and also repeating unit is the monomer without the double bond. So you should be able to draw these repeating unit and the polymer structure in short, as well as the monomer structure, right? So this is the repeating unit. Repeating unit will not have this N. Without the N, this unit is known as repeating unit, right? So if you put N, that's the polymer, right? So when naming addition polymers, we just simply use the prefix poly before the name of the monomer when naming the addition polymer. If the monomer is ethene, the polymer is polyethylene. Likewise, if the monomer is propene, polymer is polypropene. Monomer is vinyl chloride, the polymer is polyvinyl chloride, right? So the polyethylene is used in the manufacture of bags, plastic bags, boxes, the bottles, the plastic bottles, even the drinking bottles, they use this polyethylene, even though they're toxic, carcinogenic, they're toxic, right? You have to make sure that your bottle is HDPE, at least that's less harm for the body than LDPE. But you get these mineral water bottles, right? They're all LDPEs, right? LDPE is very harmful. That's why in US they say drinking tap water is more safer and more healthier than drinking the bottled water, because bottled water comes in the plastic bottle. We call them as plastic water because you have tiny particles of plastic in it, right? It goes and clogs your kidneys. It causes kidney damage and so many other complications from this plastic bottle. So at least if it is HDPE, then it's quite safe, but not 100% safe, but it's much better than the LDPE. And you also notice a number. If you take in your plastic bottle, if you have one, right? Of course, we advise you to have the glass bottles, or you can use the metal. You have the stainless steel bottles now. It's much more handier because glass bottles are practical. Sometimes it's difficult to carry here and there. So if you see number 6 or number 5, you can say number 5 and above, you see at the bottom of the bottle, you see this recycle sign, and you see a number and written as HDPE. If it's HDPE, quite better, and if the number has to be above 5, right? If that's the quality of the plastic. Now, if below 5 means it's very dangerous for the health, right? So you can check for yourself. Now, usually if you take the mineral water bottle, you see number 1. Number 1, that's why it's only one time use. You should never reuse those mineral water bottles by refilling them and reusing them. They are not meant to reuse. It's very harmful, right? So this is HDPE, at least number 5 and above, it's quite safer to use. So that is the application of the polyethene or polyethene, right? So the monomer, the polymer structure, and in short and in detail, this is a polymer structure showing many repeating units. This is a polymer showing one repeating unit. And always remember, when it comes to naming addition polymers, you use the prefix poly before the name of the monomer, right? Clear? Any questions? If not, you can copy this. This is on page 13 of the tute. Page 13 of the tute, yeah. Let me know once you're done. Okay. Anyone needs more time? Hurry up, please. Right. The next polymerization is polychloroethene. It's also referred to as polyvinyl chloride. So it's the same process as the polyethene. Let me use the same diagram to draw. This is only difference is the monomer. The rest of it, everything is same, and this n number doesn't apply there because it's different number. So you have the monomer vinyl chloride, right? Vinyl chloride, that means there's a chlorine over here, and the polymer is therefore polyvinyl chloride. This is chlorine. That chlorine repeats throughout the structure, and this is the monomer vinyl chloride. That's a common name, but the systematic name here is chloroethene, and the polymer is polyvinyl chloride. In short, we say PVC, right? PVC. Right, so everything else is the same, so only difference is the monomer. So it's easy. if you know the how one of the monomers, two of the monomers combine, then you can combine many of the monomers to form the polymer polyvinyl chloride, right? Yeah. In the given space here, you can copy the whole thing again. Now, this particular representation of the polymer is the polymer showing many repeating units, right? But this is a short form to represent the polymer. That means you show one repeating unit, put a square bracket, and put n, right? But sometimes at the exam, you notice they say to draw the polymer showing 3 repeating units, and you should draw only 3 repeating units. In that case, you should never put a square bracket or put n. Square bracket and n is used only for the if you're using a single repeating unit to represent the polymer. Please copy this on the next page. There's a question why the first bond in the polymer is a double. No, it cannot be a double bond. There's no double bonds in these addition polymers because especially the carbon-carbon double bond is not there. Because across the double bond is how the monomers combine. The monomer has a double bond because its polymer addition reaction takes place across the carbon-carbon double bond, but there's no double bonds in the polymer structure, right? So at the end of the polymer, you have to show some dotted lines like this to show that it's a continuous process. Clear?